This unit is define a schema for an external service. It's the second unit on the external services module on the Admin Intermediate Trail. My name is Jeff Alhadeff. You're welcome to join me as I work my way through this unit on Trailhead. If I come across something that I found useful, I'll link to it in the description below, so you could just jump right to that. Or if you just want to listen to me read it out loud and try to make sense of it as I go along, you're more than welcome to. Okay, after completing this unit, you'll be able to describe the purpose of a schema definition. I typically like my learning objectives to at least make a little bit of sense in English. And I'm just feeling like this one doesn't jump over that bar. So I don't understand what this means, but we're going to power on. Explain elements of a good external services schema definition. Ditto. Name 3 issues that can cause your schema to fail. Okay, that actually, I don't know if I would use the verb name, maybe identify, because that's something that we're going to be testing again. So that's a little bit more. They're actually not asking me to name them. I'm not going to just like say the names. But identify 3 issues that can cause your schema to fail. That seems like a, I don't know what a schema is, but there's things that could go wrong with it. What's a schema good for? What's a schema? Whether or not you're the one who ends up defining a schema for your external services registration, it's helpful to understand what it's good for and how it's used. Okay, I feel like that could be rewritten. If you're already familiar with defining a schema from a REST API-based API, feel free to skip the next section and what's a good schema. In other words, okay, so basically this is saying, if you're already familiar with defining a schema from a REST-based API, feel free to skip to the next section and what's a good schema. Basically, just jump right down to the resources. Okay, so let's start with a schema specification, the REST-based API that comes from an external service provider such as a bank. We mentioned in the previous unit that you can think of the specification as a contract. I honestly don't remember that. We could have. It contains what types of inputs and outputs you can include in the calls or requests. Which one is the developer jargon term, a call or a request? They both sound like jargon to me. That your org makes to the external service. For example, your calls, okay, apparently calls is the jargon because we're using it again. For example, your calls might include ID as a numerical input or a name as a text output. It also contains the endpoint information. I think I just smacked the microphone, sorry. It also contains the endpoint information and authentication parameters for the REST-based API web services that you can access. Remember that the endpoint exposes the web service resources that the external services interacts with. For example, this endpoint from a fictional bank includes methods for adding and deleting accounts. God Almighty, this makes no sense to me. Note, typically you'd perform an authentication step before accessing a bank's API. Duh. On the other hand, the schema definition is human readable, structured data. Let's look at the schema together. The snippet from the schema definition contains information about a get method. If you don't know, a get method simply retrieves information from a service. A pizza delivery service? What's a service? This particular get method gets information about an account using a resource path. In this case, /accounts/account name, where the bracket account name is a specified account. If you look under parameters, you can see name, account. The parameters must match the account name that you specify and is required. Required is true. It should take the form of a string. And when we say string, we mean a bunch of text, not like a piece of rope. By the way, why is this funny? Okay, I just want to say I'm happy that I'm recording this on video, because if I was not, I would totally not pay attention to this. Jump to the end and just try to pass the quiz. But no, I have to learn this. So here we go. Paths. Accounts from account name, and then we're going to get, and then we're going to do the operation ID, get account, summary, retrieve an account, description, retrieves the account with a specific name, consumes, text plain, procedures, application, JSON, however you pronounce that. Parameters, name, account name, end path required true, type string, description, name of the account, response is 200. Description, the response from the system finds an account with a given name, schema, $ref. I'm cracking up because there was what was that TV show? It's going to drive me crazy. Okay, I found it. The $ref here, for some odd reason, reminded me of this episode of Glee. Let's see if we get the volume up loud enough so you could hear it.
Tick and also talk by rapper key $ha.
Key $ha. Yeah. Anyhow. Okay. That was totally random. This is what happens when you have a non-developer trying to figure out this stuff. I need to learn JavaScript. I've got like the thing in the video down below that I've been working on, and I need to pick up on that in the description. That's the course I'm working on, but goodness, I need to focus on that when I finish this full time. There's a lot more to the schema, of course, but you can see that while it's designed for consumption by external services, it's certainly human readable. It's just that it's formatted in a logical way that allows external services to process the data so it can generate Apex actions. These Apex actions are where we later use inputs and outputs in a flow. The next steps are used to declarative tools to register a service, but first let's cover the elements that make up a good schema definition. I don't think this really meets the human readable. I mean, this unit seems like it assumes you don't know any programming language. And so therefore, I mean, to me, this doesn't qualify as human readable. If this script was hanging around in the bathroom, I wouldn't just like pick it up and look at it because I was bored. Like that's not what I count as. I mean, it's not just zeros and ones, so that's good. Any case. The next steps are used to declarative tools to register your service, but first let's cover the elements that make up a good schema definition. And what's a good schema? Okay, now we know that what a schema, or more precisely, a schema definition is good for. I don't know what a schema definition is good for. You could think of a schema as a specification, as we mentioned previously. You could think of the specification as a contract. Is a schema a specification? I think so. It contains what types of inputs and outputs you can include in the calls or requests that your org makes to the external service. For example, your calls might include ID as a numerical input or name as a text output. Okay, so a schema. Okay, so in terms of what is a schema good for, because it seemed like we already learned that. A schema seems to me to be good for identifying, thinking of it as a contract. It contains what inputs and outputs you can include, and that's what a schema is. The schema also includes where you could find this information, and that's called the endpoint information. So which is just basically a URL that we're going to be using to access. And then also how we are going to authenticate to get permission to see that endpoint. And then we see this as an example. This is an example of a schema definition that contains a get method. This is how we're going to get information. It includes the type of information that you're able to get, retrieve from the service. And the sort of responses that we're able to get there. Okay. That's what a schema is good for. I'm going to jump down to what is a schema definition? So we know it's human readable. File that external services consumes to generate Apex actions. That flow creates the parameters. So it is just formatted in a logical way that allows services to process the data so you can generate Apex actions. Okay. It's human readable and structured in such a way that we could then run Apex actions. That's a schema. A schema is human readable. If this counts as human readable, that's debatable, but a schema is human readable that tells you what sort of information you can get and is structured so once you retrieve that information, you could then run Apex actions. Apex is the programming language used within Salesforce, I want to say. Strongly typed object-oriented programming language. Strongly typed is a concept used to refer to a programming language that enforces strict restrictions on intermixing values with different data types. Okay. Okay, and what is a good schema? And what's a good schema? Okay, we now know what schema, or more precisely, a schema definition is good for. It's good for defining what information you could get. But what makes a good schema definition? What makes a schema definition good? And can they really be bad? Well, yes, a schema can be bad. Although a schema is human readable, it also requires logical structure that allows external services to consume it. If a schema isn't structured correctly, the external service returns error and exception messages. So let's get the skinny on what a good schema looks like to ensure that our flow can successfully consume our external services generated Apex classes. Ugh. When creating a schema, we must ensure that schemas include 100,000 characters, but no more. Reserved names are not used. I don't know what reserved names are. Only supported methods are included. Properties include values. Parameters have names. Response code output doesn't contain complex objects. Oh, and we use intergent hyperschema using JSON on or Swagger Open 2.0. Intergent. Interagent. Interagent? I think I misread that before. Interagent. Okay. If you use Swagger, okay, so these are interagent hyperschema using JSON or Swagger Open API 2.0 are if you use Swagger, you can use the Swagger editor to validate that your schema compiles with the Swagger specification. If you want to take a short detour, go ahead and copy the schema from schema editor. Be right back. Okay, I created a Swagger account. Hmm. 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 Okay, so let's just imported this into this editor. Title, external services for demo bank. Description, external services for demo bank. V, cap, service name, demo bank REST services, security definitions, basic auth, type basic, security basic auth, tags name, demo bank REST services, path /accounts /accounts name, operation ID, get account, summary retrieves an account, description retrieves the account with a specific name. Okay. Okay, I guess that's what I did. Cool. We covered some concepts about schemas and some requirements. Want to dig and get your hands dirty? Not really. You're not going to get your hands dirty. You're working with a computer. Hopefully you're not getting your hands dirty. If you're getting your hands dirty, you're doing something while working with a computer that you shouldn't be doing. With external services, of course you do. We do just that in the next unit. Before moving on, though, let's look at 2 steps we discussed. In the first unit, an external service provider such as a bank shares its REST-based API schema specification. We receive this information from our fictional bank. Based on a specific specification, a developer, or maybe even you, creates a schema definition that describes the API. While we didn't create this schema ourselves, we reviewed the elements of a schema that requirements for a good one. When you work with external services, you or your developer can define the schema you need for your use case. Okay, so a good schema is less than 100,000 characters. I don't know what reserved names means. Supported methods are included. It doesn't have anything in there that you can't actually do, maybe with Apex. Maybe that's what that means. Properties include values. I don't know what properties including values are. Parameters has names. Again, I don't really know what those things are. And there's no complex objects. Whatever that means. Like a Rubik's Cube is a complex object. Okay, which of the following are good elements of a good schema? Response code output contains objects, parameters, and has names. Response code output does not contain complex objects. Any methods can be used. Schema has less than 100,000 characters. Parameter has names. Schema has less than 100,000 characters. Yeah, okay. And what might cause your schema to fail if it includes names that is not reserved? Let me give this a shot. For some reason, I messed up on the last question. Yeah, just read it carefully. Okay, thanks for watching.